Hey guys, Mr. T here. This is another video on scale diagrams and bearings. So you'll be required to combine the use of scales, which is the the middle part of this particular topic, and with bearings, which is the last part of this topic. So you'll be using scales and scale diagrams and combining it with bearings compared to true north. So this can be useful for solving real life problems involving directions and distances without using trigonometry. So let's do an example here. In an open water swim race, swimmers must first swim for 1,000 meters on the bearing 105 degrees to buoy A. They then swim 800 meters on the bearing 0 to 0 degrees to buoy B. Draw a scale diagram to display this. Pretty much you're drawing a map of the race using an appropriate scale. And B, how far and in which direction must the swimmer swim to return to the starting point. So, to answer A, we need to decide on a scale. Now, because you're writing on pages and everything, you are going to be working in centimeters. So you are being given the choice to provide or devise a scale. You need to, in your head, think about what you're going to be drawing. You're going to be drawing something that's 1,000 meters in real life versus 800 meters in real life. And I need to get a scale that's going to break that down, to fit on my page, down to centimeters. Now, if I'm looking at this is, if I remove 2 zeros from both of these, you've got 10 versus 8. So really, on my page, I'm going to want to be drawing 10 centimeters to 8 centimeters. This would be 10 centimeters on my page, this would be 8 centimeters on my page, and that's going to help me just devise the scale to use. So let's use the 1,000 for example. I want 10 centimeters to represent 1,000 meters. To represent 1,000 meters, and 1,000 meters is how many centimeters? Well, times by 100, so 100,000 centimeters. Therefore, if I divide both of them by 10, that's going to be 1 centimeter represents 10,000 centimeters. And so that tells me the scale there. 1 is to 10,000. The other way of representing that would be a scale bar. So you're not going to be able to see this on your screen, but I have a ruler here. The scale bar, I'll just draw one here. I'll draw a scale bar 5 centimeters long. New box every centimeter. Color them in. So that's 0. These are measured to be 1 centimeter each. And 1 centimeter is going to be 10,000 centimeters in real life, so it's going to be 100 meters, 200 meters, 300 meters, 400 meters. So the scale bar is another way of representing this scale of 1 to 10,000, because if 1 centimeter is going to represent 10,000 centimeters in real life, 1 centimeter is representing 100 meters, which I can show in either of two ways: the scale bar there or the ratio. So that also gives me the scale factor, which sometimes we call K, is going to be the real life measurement, real over drawn. The real is 10,000 over the drawn, which is 1, so the scale factor is 10,000 in the chosen scale. And that'll let me work out certain things. Using the scale factor formula, for example, what am I going to draw with a scale of 1 to 10,000 for 1,000 meters drawn is going to be actual length divided by scale factor. The actual length is 10,000 meters, which is 100,000 centimeters divided by the scale factor of 10,000. 100,000 divided by 10,000. Should have been able to do that in my head anyway. It's going to be 10 centimeters. We can do the same thing for the 800 meters we need to draw. 800 meters is times by 100 for centimeters. 80,000 centimeters. Divide that by the scale factor of 10,000. 80,000 divided by 10,000 is going to be 8 centimeters. So I'm going to draw two lines. One is going to be 10 centimeters long. The other is going to be 8 centimeters long. Now we can decide on the directions. But I'll just write another indicator here. This is from start to buoy A. And this one is from A to B. And we don't know the last thing. That's what we're trying to work out in question B. So we have a little setup here. We know what the scale is going to be. Let's do this. So I'm not sure what direction this diagram is going to be, so I'm just going to start in the middle. S for start. We're going to be going on the bearing 105 for 1,000 meters, which is going to be 10 centimeters. So 105, I need my protractor. Get that out. I haven't done true north yet, so I need to indicate that. Line up the ruler with the edge of the page. Square it up. True north there. Now I can use the protractor. Oop. Turn it around. Line up 0 with true north. Yes, it's not playing well with me today. Sorry about that. Line up 0 with true north and put the center of the protractor at the point, the starting point. It moves slightly, but we'll just have to deal with it. And it's going to go in the direction 105 degrees. So clockwise, 90 degrees, 100 degrees, 105 is going to be this line here. So we can draw that. And they went 1,000 meters, which is going to be 10 centimeters on this particular scale. So unfortunately you can't see it. I have a ruler on the screen. I'm going to line it up with that point. And I'm going to draw a line 10 centimeters long. So out to here. You won't be able to check that it's 10 centimeters long because you're going to be a weird zoom. So that is buoy A. And that was 1,000 meters, which is drawn as 10 centimeters using this scale. So that's 105 degrees true. So that's part of my diagram, 1,000 on the bearing 105 degrees to buoy A. They swim 800 meters on the bearing 20 degrees to buoy B. So I haven't really chosen well the positioning of this, but that's okay. We can scroll out. So from buoy A, they go to buoy B on the bearing 20 degrees. So we need to set up true north again at buoy A. True north there from buoy A. Can I grab this protractor? No. I need a new one. So from buoy A, we're going to go... Forgot what it was now. I'll just set up the protractor here. I know it was less than 180. So try and center on buoy A, line up 0 with true north. So check the question again. They're going to go on the bearing 0 to 0 degrees. So clockwise, it goes from true north to there. That's 20 degrees along that line there. So now, according to my scale, I need to draw an 8 centimeter line from A in that direction of 20 degrees to the next point. This is not going to be exact because my rule is not lining up, but I just want to show you in a video how this is done. So that would be buoy B, and that was 0 to 0 degrees, true. So have I done that? Draw a scale diagram to display this information. They swam 1,000 meters on the bearing 105 degrees, true. Yes, I've drawn that. Then they swam 800 meters on the bearing 0 to 0 degrees, true, to buoy B. So the only thing I haven't indicated is 800 meter swim there. So that is the answer to part A. I wish I could move it and line it up nicely, but I can't. How far in which direction must the swimmer swim to return to the starting point? So here we need to construct another line from buoy B to the starting point, which will then let us work out the direction and the distance. It's not going to be exact. I'll probably get slightly the wrong answer, but that's what you get when I'm trying to do it as a video and not super accurately. So, the direction and the distance. The distance will be easy to find. I just need to measure this line here. It's 13 centimeters. 13 centimeters drawn. So we can use the scale diagram formula. So we're answering B now. Actual length is going to be drawn length times by scale factor. Drawn length, it's 13 centimeters times by the scale factor, which was 10,000. 13 times by 10,000. 13 times 10,000. 130,000. And that would be centimeters. Convert that to meters, therefore, jump it twice that way, divide by 100 to get into meters. 1,300 meters to return to the starting point. To get back to start. Now we need to find the direction. Unfortunately, I've drawn all this stuff in the way of... No, I'll just leave it to get back to start. I need to get true north for B. I need the direction back to the start, so establish true north from B. I've done my working out in front of it, unfortunately. That's true north. Now, you can see that the direction it's gone is beyond 180 degrees. That's the direction that it's gone. So we need to do some working out here. What we can do 2 protractors. So there's one, that's 180 degrees. It's so hard to line this up. It's close enough. It's not lined up exactly, but it's going to take half an hour to do this if I don't just deal with it. That's 180 degrees there, so I'm going to put a dot. And what I can do is I can rotate that further. This rotation is terrible. So centered, it's gone to so up to this point it's 180 degrees. Now we just need to work out what this leftover part of the arrow is. So it's gone 0 here to 68. So clockwise, going all the way around from true north here down to the bottom is 180 degrees, and then we've gone a further 68 degrees. So plus 68 degrees, therefore 180 plus 68 is going to be 248 degrees there. So I'm going to answer this question somewhere where it's less messy. So B, swim direction 248 degrees true from B back to start, and we said it was for 1300 meters. Alright, so after all of that working out, we've been able to answer question B using all the techniques that we've done before. You'll have to have a think about what is assumed here. We're assuming that people are actually swimming and going in their exact directions that they're meant to go, and we're assuming that there's no errors in either the distance measurements or the bearing measurements. So, hopefully all of that helps you out, and I'll see you in the next video.